Hi. Today we'll learn how to find the determinant of 3x3 matrices, but the techniques can be applied to 4x4, 3x4, or larger matrices. There are three techniques that we must know how to do manually, and the fourth one is using the calculator, but that option may not be available in exams, so you need to know one of these three well so that you can find the determinant of matrices that are 3x3 or larger. So let's look at the first method, which is by row operations. In this method, our goal is to take a 3x3 or larger matrix and achieve placing zeros at these three positions. Okay. Note that the red diagonal will be used to find the determinant, and on the right upper side we'll have any numbers. It doesn't matter what numbers. And note that for the red diagonal we don't need ones, we can have any numbers. So this matrix is called the upper triangular. We must achieve that. So let's see how we do it. Here are three matrices, matrices A, B, and C. Let's find the determinant for matrix A using the row operation method. So we take a look at it, we see a number there, that's what we want, we're good. We take a look under it, we see a zero, we're good. We see this zero. Now we need two zeros more on this position and this position. So our goal is to devise some row operation to get a zero where this 2 is, and we write a rule for that. Note that I must get a 0 with some multiple of row 1. So row 1 times what? Gives me the opposite of positive 2, meaning row 1 times minus 2 gives me minus 2. I add the minus 2 to the plus 2, I get a 0. So here's the rule. Minus 2 times row 1. I add it to row 3, and that will give me a 0 in row 3. So let's see that matrix now, applying this rule. Note that row 1 and row 2 are not changing, so I'm going to copy them as they are. No change for these rows. And now I apply the rule for row 3. Minus 2 times 1, minus 2 plus 2, 0. Minus 2 times minus 2 plus 4, add to minus 4, 0. Minus 2 times 2 is minus 4, add to 1, minus 3. Now the determinant, note that we achieved all zeros here, so we achieved this shape. Now the determinant is going to require that we take a minus 1 and put a power showing how many row interchange we did to achieve this format. Well, we did not do any row interchange, so the power is 0. This is always going to appear in this type of method, in the row operation method, okay? Where this power is how many row interchange were done along the way. So 1, 2, 3, or 0, like our case. And now the red diagonal that I showed in the beginning is actually this diagonal. So we multiply that diagonal, 1, 5, minus 3. Multiplying all of this, note, any number to the power of 0 is 1. And multiplying all of this, we get 15. So actually minus 15, and the determinant is minus 15. Now, applying the same method to matrix 2. In matrix 2, we take a look at it, we see a 0 where we want, but there is another 0 here, and we wonder, no, it might be nice to move this column, this row down here, so we get 2 zeros where we need 2 zeros. Then we move this row up, so there will be a row interchange here, row 2 interchange with row 3. We rewrite the matrix. Row 1 does not change, so we rewrite it. Now the rows interchange, so here we have minus 9, 4, and 2. And old row 2 is now row 3 with this. So now we are pretty close to achieving that shape. We just need to find a way to put a 0 where there's a minus 9. So the rule is 3 times row 1. That gives me positive 9. When I add to negative 9, I get a 0. So I add to row 2 into row 2. I rewrite the matrix. Row 1 does not change. Row 3 does not change. So what happens to row 2? Apply the rule. 3 times row 1, 9. Minus 9, 0. 3 times minus 2, minus 6. Plus 4, minus 2. 3 times 1, 3. Plus 2, 5. We achieved the shape. So we are going to say minus 1 to the power of row interchange. We did have 1. So 1 multiplied by the diagonal, 3 times minus 2 times 5. Note, here's the power of 1. So we are going to keep the negative 1. 3 times minus 2 minus 6 plus 5 minus 30. And when we multiply these two, we get 30. So this is the determinant. Applying the row operations method. Matrix number 3, or matrix C. Take a look at it. There is no 0 anywhere. There is really nothing to be done here. So let's start making rules. So let's see. We want a 0 here. So if I take twice negative this guy, I get a minus 2. I add 2 plus 2, I get a 0. So minus 2, row 1, add to row 2, put that in row 2. How do I get a 0 here? Oh, I just add. I add row 1 to row 3. I add this guy here. So it's row 1 plus row 3. And I put that into row 3. So let's rewrite that matrix down here. Note, row 2 and 3 are changing. Row 1 stays the same. So I'm going to copy it for 2. Now, what happens to row 2? It's minus 2, row 1 plus row 2. Minus 2 times 1 minus 2 plus 2, 0. Minus 2 times 4 minus 8. Minus 1 minus 9. Minus 2 times 2 minus 4. Plus 3 minus 1. Now, rule for row 3. In row 3, we add row 1 to row 3. That's it. So 1 minus 1, 0. 4 plus 3, 7. 2 plus 1, 3. Now, I take a look at this matrix, and I see that if I take care of this 7 by turning it into a 0, I'm good, and I can find the determinant. How can I make this 7 become a 0? By using a multiple of this row. Well, why not a multiple of this row? Well, because if I use that row, this one is going to end up where my 0 down here is, and that will mess up my 0. So it has to be a multiple of the second row. So when you're looking for these multiples, there's a little algebra, but there's a simple way to solve this. To turn this 7 into a 0, I need a minus 7. Well, I already have the negative sign on the 9. So I already have that. I need some multiple here that gives me minus 7. Because then I add this to the positive 7, I get a 0. So who goes here? Well, it's just a flip of the 9 and the 7. So it's a flip, it's 7 and 9. That's it. So now I'm multiplying. It's a multiplication here. I'm multiplying this. However, look, this is negative 9, positive 9. I cancel them out. Note, I cancel the numbers, but not the sign. So the sign stays. And it gives me a minus 7. When I take this minus 7 plus the 7, I get a 0. Okay? So the rule is row. Oh, hold on a second. It's not row. We're going to say that the multiple comes first. 7 over 9, 7 over 9, row 2. Then I add that to row 3 and I put the result in row 3. So let's see what happens. Note, only row 3 is changing. So row 1 stayed the same. I copy it. Row 2 stays the same. So I copy it. Row 3 change. So that multiple times 0 plus 0 is 0. That multiple times 7 times minus 9. So 7, 9. Hold on a second. Okay, that multiple 7, 9 times minus 9. Okay, this will give me minus 7 plus 7 equals 0, 0. Now, that multiple times minus 1 gives me minus 7, 9 plus, no, plus this guy here, it's a 3, plus 3. Now, we get into the old LCM stuff here. How can I write this 3 with the denominator 9? Well, it's 27. Because 27 divided by 9 is 3. So this 3 is actually 27 over 9. Okay, so I'm going to rewrite that 3 as 27 over 9. So here I get 27 over 9. So this is negative 7, 9, positive 27 over 9. I get positive 20 over 9. So in this corner, I get 20 over 9. What is the determinant? I'm going to put this in red now because it's getting a little tight there. And I do want you to see the solution nicely. So that minus 1 to the power of how many row interchange we did. In this operation, we did not do any row interchange, 0. Now we multiply by the diagonal we got. So let me get that to show. That's the diagonal. And it's 1 minus 9 and 20 over 9. Okay, so we have the minus 1 to the power of 0 times 1 times minus 9 times 20 over 9. This will give me a 1. 1 times 9 is times minus 9 times 20 over 9. However, these 9's cancel out, but not the minus sign. Okay, so I get actually 1 times minus 20, which is minus 20, and this is the determinant using the row operation method. Okay, now let's move on to replicating the matrix method. And in this case, we are going to just copy the matrix. 1 minus 2, 2, 0, 5 minus 1, 2 minus 4, 1. Put a line here and copy the matrix again. 1 minus 2, 2, 0, 5 minus 1, 2 minus 4, 1. And what we'll do now is this. We take a line going up and multiply these guys, which gives us 0. A line going up, multiply these, minus 4 minus 1 is 4, positive, times 1, 4. A line going up, 2 times 5, 10, times 2, 20. Once we have multiplied, we add them up, we get the 24, and now we flip the sign, it is minus 24. Now, I'm going to put color here, so we want to see what's next. Next is going down now. We go down here, multiply, 2 times 0 times minus 4 is 0, going down. Okay, minus 2 times minus 1 is 2, times 2 is 4. And the third step, going down, 1 times 5 times 1 is 5. We add them up, and this will give us 9. So we are now going to find the determinant, and the determinant is going to be the sum of these two. Note, do not do not flip sign. Okay, you do flip sign on the when you multiply it and add up, but not down. So the determinant is going to be minus 24 plus 9, so the determinant equals minus 15. So we're using the replicating matrix method. We got minus 15 for matrix A, and that's what we got over the row operations method. So they match and we are good. So now you can do your own calculations to find that the determinant for this matrix 30 and the determinant for this matrix is minus 20. Just apply this technique and you get the determinant. The third method now is cofactor expansion. It is not the student's favorite, it is book's favorite. So let's see how it works. First, we select a row or a column that has the most zeros. So we're looking for here most zeros, okay? Because that way I work less and therefore I make fewer mistakes. So let's say here's a row that has 1 0, so I have to do work for that number 5 and that number minus 1. Let's see how it goes. I don't need to worry about the 0, I worry about the 5. There's the 5, I multiplied by minus 1. Now, to the power of that number's position on the grid, so the grid is row 2, row equals 2, column 2. You can count second row and you can count the second column. So the power of that minus 1 is going to be 2 plus 2. So we write it here. Now who goes here in this submatrix or smaller matrix? This is what you do. To find who goes there, you cross this row and you cross right over the 5 because you're working on the 5. So who shows now is 1, 2, 2 and 1. So you write them here, 1, 2, 2, 1. Okay. Now we add. Well, before we add, let me clean up this mess here. Okay, cleaning up, cleaning up, cleaning up, cleaning up, cleaning up, cleaning up. All right. So I cleaned up the mess. We add who? Well, we're going to work with the minus 1 this time. So minus 1. Now, this minus 1 is the guy from the matrix, but we still have to put the other minus 1 to the power of this minus 1's position. Okay, this minus 1 is row 2, column 3. So this is row 2, column 3. So the power is 2 plus 3, 2 plus 3. The submatrix now, we put a line over the 1, a line over the column where that 1 is. Who is left? Left are 1 minus 2, 2 minus 4. Okay, so what do we do now? We write it here, 1 minus 2, 2 minus 1. Okay, now we can start working. So let's see. We have a 5. Now, the power is positive. 2 plus 2 is 4. Okay, so we have a positive power. So multiplied by minus 1 is going to give us a positive 1 because the power is positive. Okay, now how do I find the determinant of this submatrix? It's just a 2 by 2. So the determinant is go down, multiply, 1 times 1 is 1. Minus, multiply upwards, 2 times 2 is 4. Okay, now let's see what happens here before we put any sign here. This minus 1 is to the power of 5. Okay, so minus 1 to the power of 5 is still minus 1. Now this other minus 1 is the guy from the matrix, so we're just going to say minus 1 here. Now who is the determinant of this matrix? You multiply downwards, that gives us minus 4, minus multiply upwards, and that is 2 minus 2 is minus 4. I have a minus 4 with a minus sign already sitting there, then it becomes plus 4. Okay, so we made some progress. Let's see what we have here now. we have 5. Out of here comes minus 3. Here we get a 0. Let me double check these numbers are correct. Minus 2, 2 minus 4, they are all correct. So I have a 0 here, and therefore everything else will become a 0. And then we get for this matrix minus 15. And by the way, this is matrix A, okay? We just found it's minus 15 on the second method, and we also found minus 15 on the first method. So now we used all three methods, and we found minus 15. So all three methods are finding the same determinant. They are all correct. Now, here, let's see what we're going to do on this one, on matrix B. And note, we're using cofactor expansion here. Let's take the row with most zeros, and this is a nice row for us because there are 2 zeros. We don't need to work on those. Alright, so we only have work for number 5. Okay, minus 1 to the power of the 5 position. Row 2, this is row 2, this is column 3, so 2 plus 3. Submatrix, we cross this row, we cross this column, we have left 3 minus 2, 3 minus 2, minus 9 and 4, minus 9 and 4. Okay, this will give us 5 times, let's see, odd exponent, we keep the minus 1, and the determinant of a 2 by 2 is these 2 multiplied, 3 times 4, 12, minus these 2 multiplied, that's a negative 9, negative 2, plus 18, so it's minus 18 because we already had that minus sign there. This will give us minus 5 times 12 minus 18 gives us minus 6, and multiplied gives us plus 30. So method 1 for matrix B gave us plus 30. Method 2, we didn't do it, but I said you do it and you get 30. And method 3 gave us 30. So now you apply these same ideas to this matrix, and you are going to get determinant of minus 20. Note, there is no rows of 0, so you're going to work 3 times here, and all 3 times you're going to look at the position of the number you want and take the row and column and use that to find the power of this minus 1 that goes into all of them. So you have 2 numbers here, plus you add them, you don't multiply, you add them, okay? And you should find minus 20. If you don't find minus 20, then you made a mistake, redo it. Now, using the TI-84 to find the determinant, so you can double check your work because you could write any matrix, find the determinant by any of the 3 methods, and then come to the TI-84, punch the matrix in, and see if your work is correct. And you repeat this many times until you're confident you can go into an exam and get an A. So let's pull the calculator. Here's the calculator. To get to matrix, you push second, and the reciprocal x with a minus over it is an exponent, negative. So this is the reciprocal key. It turned red now, you can see it. All right, and you can see that I already typed all 3 matrices in. So let's see how we get to them. Note that you went second second matrix, and now you move over to edit. Okay, you hit enter, and you can see where the cursor is that we have a 3 by 3. So this is where you type row columns, and then you type the matrices inside here. To get out of here, once you entered all the numbers, you just say second mode. That clears everything. Now once the matrix is in, you go second matrix again. This time you move 1 arrow to the right and stop on the math menu. And note, the determinant is option 1, so you just hit enter. Now the calculator wants to know which matrix, so you go to the matrix menu again, second matrix. Now you don't pass this because you just hit enter on the A or the B or the C. Whatever the matrix you want, you just hit enter there. Okay, so I'm going to do determinant for matrix A. I am on A already. The cursor is on number 1. I hit enter, and it shows determinant. I hit enter, and there's the minus 15 that we got. Now I go back to the math menu. I hit enter. This time I take second matrix and I move over to the right. Hold on a sec, because I was on the determinant, so I want to go down to B. I move the cursor to number 2B. I hit enter. So determinant of B, and that's 30. Second matrix, right. I'm sorry, not right. C. Oops, I typed C, so I have to type the determinant first. Let me clear and start over. Okay, I want to go over to math, hit enter, there's the determinant. Now I go back there, but I go straight down to C, hit enter, and now determinant of C, enter, and minus 20. So you can double check your work by using the TI calculator like that. And I showed on the screen that we did all the three determinants, and we got the numbers we had previously calculated. You see minus 20 for matrix C. So I hope this was helpful. Make sure you do practice a lot at home. One of the 3 methods, whatever method your teacher told you to learn or the book focuses on, use the TI to practice. See if you got the right solution. Stop this video, pause it, redo the work I did, see if you get the same numbers, and I wish you good luck. I'll see you next time.